The unit that your students are in right now is place value. And in second grade, it's a really important time because we're moving up strongly from the ones and tens into the hundreds. And we used to be taught a lot of things. Memorize the word that goes in the column, and then you know the number. We also found out that we memorized it and we didn't really understand it. So we're going to start off, again, behaving like second graders. I would like you to figure out how many straws are in your bucket and be able to prove it. How are you going to do that? So you're going to work as a group because I'm assuming you want to be efficient and one person counting all of them. Well, the other 6 of you might enjoy it, but it's probably not going to get the task done very quickly. So could we start off? I'll give you, would you like a hint? Yeah. There are rubber bands. That might be a hint. So please go ahead, try to figure out how many straws are in your bucket.
What do you want to group them by? 10 second graders.
As I told you, I couldn't let them help me open the packages because I could have read it. Yeah. Oh, yeah.
It's already faster. Great collaboration over here.
So what are you trying to do?
100 times.
So what do you think?
I would say 1,000.
You're going to have to be able to prove it. That was the second part of the... Yeah.
This is the only person.
There's always
interesting.
yes.
No, but it's just interesting to see all this. I guess how many we have? We have to prove it. Yes.
What are you doing now with your task? Would you like any larger rubber bands? Sure. You're a good teacher. So you got ones and tens. I could bundle them in one. We have like some large. Would you like some larger rubber bands?
Yeah.
Are you going to do anything with those?
Yeah, we can put them in 10 for like now.
Okay, I'll give you some larger rubber bands.
Are we not just counting the tens?
Will that work?
Count tens? Yeah, maybe a time.
So if you count tens, count these tens would be plenty of value.
one of the fellows already right here.
So do you want to keep, would you like to keep track of your hundreds? You have lots of tens groups. Would you like to bundle those into larger groups? Here's some larger rubber bands. Do you want more large? I almost put it. It's okay.
All that.
Really interesting. Do you need these for your hundreds? Okay. Okay, you've got about 1 more minute, because do remember, you're not really 7-year-olds, so we're just kind of getting the idea. Oh, absolutely. They make you guys okay, 10 more seconds. Okay, 3, 2, 1. Could you please take your hands off the table? It's hard. It is hard. You don't have to hold them up in the air. You can put them in your lap. So could you please tell me, I gave you an awful lot of things to count. What was your strategy to find out how many? Actually, how many are there? 611. How about your table? Give me an approximate.
2,500.
I question your approximation skills. Okay. There, on most of the baskets, there were 1,000 straws. 2 tables, there were about 750, but they probably didn't get split evenly. So if you got 611, they probably got 900, somewhere in there. But I want to talk about what you did with the straws, because every single one of the tables acted like strong mathematicians. I asked you to prove it, and you all found a system. Our base 10 system is very organized. So most of you started with 1s. Really, it took you a second and a half to figure out to go to 10s. Then there were interesting discussions about going to 20s and 50s. And at that point, I may have, well, some people want to go to 50s. It's like, well, I can't really count 50 to know that it's accurate, but 5 groups of 10s is quite easy. And then I think, if I'm correct, everybody went to hundreds, because you're well versed with our number system. The base 10 system is very unique because it's one of the few things that everybody in the world uses. Every culture uses a base 10 system and has for a couple hundred years. I know earlier there were a lot of creative things, but we use this base 10 system. And it is the foundation of how we work with numbers. So if you have all these, let me borrow yours because I didn't bring any. If this is 100, how else could we describe it? Would you turn and talk to a partner? How else could I explain this, not using the word 100? 10 tens. How many is this?
20 tens.
How many is this?
20 tens, 110.
In the past, kids would know this was 10 tens. Excuse me. If we did this, we started losing kids. They weren't used to it. They had memorized 10 times 10, or 10 groups of 10 is 100, and it stopped there. We need them to know that 2 groups of 100 are 20 tens. We need them to know that they can add 1 more group, and you can still count it as tens. You can still count this is 210 ones. And there are times, excuse me, when it's most efficient to say 20110, but when we get into subtraction and things, we need to break these apart. And we need to have the kids being able to visualize what is happening in their head, not a procedure where I have to go and cross off a 0 and mark out that one and move it over to here. That is a procedure they memorize. But if they're shown this, they know that 100 is 10 tens. They know that a bundle is 10 ones. It takes practice, it takes fun, it takes playing with these things. So this is what our lesson is about today, is how we can put these together and break them apart. We've just passed out a packet, and I'd like to go over the first page with you. It's about the vocabulary we'll be using in this unit. Shannon, steal these. Yeah, I'm just looking. I need a few bundles. I want to take it from the table because it's okay, you're reading it in front of you. I'm going to pull it up here. But we do not do this to your children. We do not walk in and throw down a whole bunch of words and say, now start using them. We build them. We talk about it. Right now, what you were doing was composing tens and composing 100s. What does that mean? You were building them. Would you please take one of the 10 bundles and take the rubber band off? I know after all that hard work, I'm going to ask you to undo one. And whether you all do it or not. What happens, what are you doing when you take that rubber band off? You are decomposing. You're taking it apart. Those 2 words are fairly new to the kids, but they will be using them the rest of their life as mathematicians because it's what we do and it's what makes us flexible. That ability to decompose, and I always want to say recompose, there's no such word. Decompose and compose the numbers. The place value chart is a tool. We wanted to give you a big one. Miss Katrina. Yes. Can you pass these out? Place value chart. This is to help the kids understand that a 3-digit number is not simply a 3, a 2, and a 1. It represents something. It represents 3 100s, 2 10s, and 1 1. They'll be using this a lot. They'll be using this to understand numbers. They'll be using this to compare numbers. They'll be using this to add numbers, and they'll be using this to subtract numbers. I think this one is fancy because I copied it off the internet. It's really only drawing 3 lines. You'll probably see them start writing H, T, and an O. When you see that, go, cool. What does that stand for? We don't want them to have memorized H, T, and O, but we can appreciate the efficiency of them shortening it, but we want them to make sure they know what it is. We have a lot of words for numbers. Unit form means we are talking about how many units of hundreds do we have. I want to be able to refer to a number. Somebody tell me favorite number between 1 and 9. I need one more.
7.
I need a different one, just not to confuse us. 5, okay. So if I'm going to describe this number in unit form, I have 8 hundreds, I have 7 tens, and I have 5 ones. The number is 875. We use that a lot when we're talking about it. But when I go to manipulate it, or when I need to compare it, or when I need to do something with it mathematically, I may need to know the units that we're talking about. It's going to depend on the situation. So they use this term, 800s, 7 tens, and 5 ones. It's especially used when we're comparing numbers. The next way we describe numbers is the expanded form. And if you're following down, you'll see that they're getting, well, I was going to say they're getting a little bit more abstract as we go. So we're coming off of the chart, we went to the words, now we're going to the number. Probably should have used 589. I'll change that. So now we have 589. What does it look like? Expanded form. If you have an excellent memory, there's the term expanded form and expanded notation. There is no set rule for the definition there. At second grade, expanded form is by the units. It's 800, it's 500 plus 80 plus 9. By fifth grade, that will change a little bit. It will be 5 times 100 or 5 times 10 squared plus. It's still the same idea, it just gets a little bit more, I like the term esoteric. It's second grade, this is where we're at. No, because I've changed numbers, and I should. Thank you. And then you'll see the next one, word form. Luckily, that's what it is, exactly what it says. We write it out. We write, unit form uses a digit and then the place value. Word form is we're just writing it out. The last time you wrote a check, you had to write it out. Not sure when the last time was I wrote a check, but there are reasons to know how to write numbers. This becomes a spelling issue for kids. Give them all the help they need. If they need a chart with all these numbers written on it, good. For a child to learn to use resources is excellent. We're not trying to test them on spelling here, but we are trying to teach them the pattern of how we write it. The one, I don't know where I was. To me, this hyphen is new. I used to write it as 89. That's not a big issue. That is not changing the value of the number. It's just a habit. No, it's not a good word. I don't know if it's different in the British system, whatever, but nowadays we seem to be using the hyphen, but it's right either way. They'll probably be seeing it written as a hyphen. And our last representation is the number bond. You saw it last year. You may have seen it with 3-digit numbers up to 100. You probably didn't. They go up to 100. Last year we were breaking it into 2 digits. A number bond is simply part, whole, or in this case, part, whole. There means this is the whole number and we decompose it in some way. There is no rule about how it gets decomposed. I might have, this could be 400, 180, and 9. The term is we're conserving the value of the number. They are still equal values. We have our reasons and we choose strategically how we break our numbers apart. In a place value unit, you're probably going to break them apart by place value, but not always, because we're going to find that breaking apart 100 can help us in subtracting. We don't always have to regroup and name this thing. I can think of the number differently and it can help us. As I'm touching on that, yes, we're going to touch on addition and subtraction, but mostly this is about understanding the value of the place values. But we want to show them when they understand this, how they can use this. Why are we learning this? We don't want them to learn it because the second grade teacher or Carol says you're supposed to. We want them to learn it because it's of use for them as mathematicians. This is a page for you to keep. It's really, oh, excuse me. And then I do have the 3 symbols. The first one is less than. 8 is less than 10. Next symbol is greater than. 8 is greater than 6. Could somebody tell me, oh, I've given it to you, what that symbol says? All of us say equal. Equal doesn't mean a lot to 7-year-olds. if you put 2 desserts on the table and they're not equal, they're not going to say, oh, those aren't equal. They're going to say they're not fair. So one of the things is we're going to read that symbol a lot as same as. And there's a really, really strong reason. Because we have been teaching for years an equation like this, and kids see the equal sign and they immediately put 10. Because in their mind, equal means find an answer. I've done 100 worksheets, I know all those problems. Equal means find an answer. And they don't think about it. Now replace equal with 8 plus 2 is the same as what plus 6. And just that language, you will get a ton more kids who will automatically start thinking about this question. So this is a really, probably of anything on this page, this language can be what makes the difference to your child. The name of the symbol is equal, but right now in their developmental stage, using the same as is really important. There's one small caveat, one small thing. Let me get the proper answer out there. So what is 8 plus 2 is the same as what plus 6? There will be a child or two that says, no, they're not the same because one is an 8 and one is a 4. Stick the word value in there or quantity. Most kids don't need it. Second language learners that are the ones that we worry about when we're saying it in English and they're being incredibly literal. And to them, it's still like seeing oranges on one side and apples on the other. But if you say, but we're talking about the quantity, it pretty much goes away. And as they get used to it, they will be able to slip into the same as and they'll internalize that it's about the value. So how can we use this? We're going to use our manipulatives. Please go ahead and turn your page. Now, I'm treating you as second graders. However, they would get weeks to learn this, and you're getting 45 minutes. So I had to pick and choose what I thought were the strong points for you to practice. And you're not going to practice much, but they will. And they're going to be asked to be talking about it, not just doing. I'm going to ask you to talk about it, but you'll get one try as opposed to multiple practices. So you've got these manipulatives in front of you, and I want to know that you can count from 100 to 133 without it being rote counting and just going 101, 102, 103, 104. How can you prove that those numbers are accurate? How can you use your manipulatives to show me how you would count? Would you go ahead and work at your tables? Okay. So what I did, which was really not fair to you, is I really hadn't introduced how to draw this. I just wanted you to get to the counting. Most of us, we would say you'd start with the 100 bundle. I cannot say exactly or sure how each of the teachers is going to draw it, but it's going to look mostly like this. And they've got the straws in front of them. So that looks like my hundreds bundle. What number did you go to next in counting? 10. So I'm going to draw a 10. So I have 110. What do I go to next? Another 10 is now I'm up to 120. Another 10. 1 and a 2 and a 3. Is there another way of doing it? With 7-year-olds, you're going to start with 100 and somebody's going to put the 3. Are they correct? Yes. So I've got 103. Now I have 113. Now I have 123. And now I have 133. But it's correct. And then a whippersnapper is going to go, oh, I can do 100, and then 1, and then 10, and then 1, and then 10, and then 1, now I'm lost, and then 10.
Now, can they just have it once as well?
Yes, they could have. I think this particular problem originally said start with 100. So yes, they could have. We love the flexibility. We love the thinking. Are we going to move all the kids towards that first answer? Yes, because we use the word efficiency in math. Even while drawing the last one for you, I was starting to get lost. So we do. Our brains love patterns, and that is what is so wonderful about our base 10 system. Would we accept all these answers at the beginning? Yes. Would I challenge a kid who did the first one? I mean, this is a pretty low-level question. But a kid who thoroughly understands this, I might ask, and how many other ways would it still work? Because eventually, having that flexibility and having choices of how to deal with numbers is what makes them strong in computation. But yes, we do get to efficiency. So this would be ultimately the answer we're probably expecting from kids. Yes?
Is it possible that two different teachers use, as you just mentioned, that maybe some teachers will use a different, I don't know, maybe without the version done, for example, so two students from two different sections.
How can I
refer
say?
to the ones
Yeah.
and
They're going to look really similar. Can I guarantee that they're exactly alike? The resource that we're using to help us teach draws it this way, so they're most likely going to teach it like this.
If they really understand
Yeah,
the
so-
concept, it'll be just like seeing print in a different font.
Yeah.
It takes you back a second and then you understand the concept, so you
And,
get it.
and we are going to be using these straws, right? I can't say half the unit, I don't know how many. And then we're going to move on to a more, here goes my word, abstract one. So we're just using them now for them to understand it. If that child can tell me that's worth 100, that's where we're at. I think what I saw last year is that there were teachers who did this, H, T, and I don't, maybe a 1, I'm not quite sure. It would be similar and pretty self-explanatory. So would you go ahead and do number 2 together? Well, that is considered. Oh, yeah. So if you were able to do it one way and probably the place value way, you could see that this particular question, whether you go to tens first or hundreds, whether you need to use your ones and your tens. And honestly, there's no right answer for that. Do you go from 125 to 130 and then count up? Or do you count up? It's not right or wrong. Okay. would you simply read the last question? This is where we're getting, if you've heard the hoopla over Common Core, I stand thoroughly behind the Common Core standards. They're an excellent. But one of the ideas is that we go deeper, not broader. That last question on the page is where we're really getting kids to think and explain. I'm not going to ask you to actually do it, but I'd like you to read it so that you understand what's being asked of your child. One of our standards is that children are able to justify their own position and ask questions of others. So they're having to take a look at this and compare what two kids say and figure out who's right. As I recall, I'm not afraid to say anything off the top of my head. I believe they're equal. Oh no, this isn't the one. 3 different ways. Yeah, so could he build it 3 different ways? Absolutely. 100, 2 10s and 4 1s. He could do 12 10s and 4 1s. He could do 124 1s. If your child can answer this question saying they're equal and why, they have a really firm grasp of what our number system is doing. And they'll be able to manipulate it themselves. So, could you put the straws away? Because we're not going to leave them with straws. We know that second graders cannot walk around the rest of their life with straws in their pockets. So we're going to move on to the next level of representation. Yeah. Yes, absolutely.
For the second one on there, it says to start with a bundle of 125. So does that mean that they can do a big bundle of 125, or do you want to do 100 and then?
I think the goal of the question is they wanted counting to start at 125.
Yeah.
How they draw the 125, you could just write down 125.
So, but if you do a bundle
And if you label it
my son
125.
says that's 125, that's a bundle. And you just have to do another 100, 2 kids, and then 5.
Yes. Yes. But he could do 5 10s next. Because a lot of kids don't like staying in the 5s. They want to get, we have these things called friendly numbers. Our brains like 10s and 100s, so they might want to get rid of that 1s. And that's a perfectly, equally good answer.
But a single bundle of 125.
Yeah, that's just a starting point, yeah. So if we put the straws away, we're moving on to our more abstract way of representing things. Would you do that second? I don't think I have enough. And I would like you, using your place value chart, to build the number 312. That might be the only table you need to do it. That's correct. Can you build it another way? Anybody who got finished, I can build it another way. Okay, so now, a minute ago, we had a picture where the 100 was bigger than the 10, and the 10 was bigger than the 1. That's very representational. It's very easy to understand. We're moving them along. Now, our place value system is now telling them the value of it instead of the size of the picture. So now we have red blocks that say this is 100. That's the way our numbers work. And they're ready for it because they've built it. If any child is struggling, we put the straws back out there and we let them make the comparison. But most of them are ready to move on to this. So what do we do with this? We know how to decompose the number. And now I'm ready to start applying it to real problems. First story reads, a school book fair sold 611 chapter books and 74 picture books. How many books were sold in all? Could you go ahead and build that? Now think about when you build it, can I see the problem? You may have to work together. I don't know if there's going to be enough chips for their cup discs for everybody to build it. Right, they did it with smaller numbers. All of this math is related to each other, and it builds on it. So yes, they did it too. Are we going to go back? It's funny, we do lose kids as we get to a larger term. So yes, we go back to building it every time we introduce something like the concept. We move some kids through that faster. I would expect to see 100 start at this point. Yeah. Right. So now we've gone back to our straws model, which is fine, because that might be where you have other people are going to draw. Maybe I should show you. So if you have built it, can you take a look at what you've built and transfer it to your paper? So I built it, now I'm transferring it to the representational. I've got a really good argument.
So they're not supposed to put in the exact figure instead of...
No, we're now to an abstract picture, but my chart tells me the values. So this is how we are moving them along to the more, we're moving them.
Like 600, 110.
Are you asking, could you just do this?
Yeah.
Not on the first day, I'd say great, what would that look like? But yes, that's what we're moving them towards. But every time we start a larger number, we're going to go back to the concrete. I'm going to want to see that picture to just make sure. But yes, we will get there. I'm going to take those out just for the minute. But can we add these together? Absolutely. And do we have an answer? It is 600, this is where I don't trust myself, 75? 80. Did I not?
No, because it's how we learn.
It's because they are.
How to take their life.
Good day on that. And in addition, at this point you're probably sitting here kind of going, isn't this really obvious? We're going to go through addition because we want to get to subtraction. We want to look. Does this make sense? Are we going to move on to the numbers? Absolutely. We're going to move on to this looking like what was it, 74, and they would add it up. And now you'll notice this is starting to look a lot closer to that algorithm that we learned. But we make sure they can visualize it before we get to that algorithm. Second graders will not get to using the algorithm as their only means. They'll be seeing it towards the end of the year as a note-taking device for this. Any questions? Yes?
More of an observation. So would it be accurate to say that the reason for the change and the shift in how we're teaching this in place values is they will get to the point where they know these place values so well, the numbers, it doesn't matter what the numbers are, but they can manipulate. Is that the, in practical, we had it in that direction?
Yeah.
Is that the, okay, would you call that as a point?
Yes. And, I mean, this isn't a great problem. If we had 670 plus 74, I practically would turn around and write that down in a column to add it up. Which really, I can look at this when I'm flexible with numbers and go, oh, well, it's going to be 600, there's 8 tens and 4, and I'm done. We were really straddling a weight to the kids by saying, always write it down and do this. There are some that makes perfect sense for, and we've got all these odd numbers, and our brain can only hold so many numbers at a working time. But there's a lot of times it doesn't matter that the numbers are large, their numbers are so compatible that we could have just added them up in our brains. When we get to multiplication, they tend to be kind of pretty numbers that they should not be writing down these 4 partial products. They should be going 800, 920, 980, 983. And that's the flexibility that we want. Yes?
So the right of the RWT or the RDW is right now 685, right? Or they have to write something, like as.
Let me see if I understood.
Yeah, the W
The right for this in 2nd grade, the answer should be written down.
like 600.
There are 685 books sold. There were 685 books sold
So
at the.
not just the number, not
No.
685.
No. They're not asking for word form. They're asking that they understand that 685 is answering a question. We know that they understand that by writing it in. They sold 685 books. And that end sentence is one to put the number back into the context of the story. It also is somewhat of a check for a lot of kids, not all of them, that it has to make sense to the story. So if they got the answer 12, this is a great one, if they subtracted instead of added, it's that last check of, wait a minute, that really makes no sense to what the story was asking. Doesn't always work, but it's one more opportunity. I'm looking at the time. Usual with me, I can talk and talk and talk. Would you?
I would actually like to see number 5. Going to be exceeding. So 97 plus.
Oh, great.
10.
So can we just do this together here? We've got hundreds, tens, ones. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3. We're adding 97. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. I'm going to say one thing. As your children were in kindergarten and 1st grade, we used 5 frames and 10 frames. They were where you put your dots. I'm doing this to my face. 5 is a very recognizable number for them. So a lot of teachers have them write their numbers in the first row of 5 and then fill in the second row. It doesn't make it right or wrong, but it's one of those things, the pattern that our brain sees easily. So what are we going to do here? We need to find groups of 10. Doesn't matter which 10 I pick. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have a 10, I need to move it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I've got a 10, I need to move it over here. So this is back to that knowing that 10 ones equals a 10. 10 tens equals 100 that we did earlier with the straws, which they did a lot more of. If you go back to our standard algorithm, what did I just do? In the olden days, I said 3 plus 7 is 10. I wrote down a 0 and I carried a 1. not language we use anymore. What did I just do here? I counted up my 10. I put my 10 over into the tens place. So it's just a stepping stone as we get more abstract.
I think that's why those pictures are so critical, because the language can be very confusing with the old way was that floating one hanging over, it's not the, so the language is important, and the picture making really helps reinforce the concept, which is why it's so critical to start with the picture instead of just putting the numbers right in there right away.
There will be a few changes to the standard algorithm. Just some child psychologists say, why are you putting up the 1 at the top? Why don't you put it down at the bottom where you can still kind of sort of see it? It doesn't change the value at all, but I thought it was a really good argument. It's like, yeah, so I can still kind of see 10. I can still kind of see 13, which is in my picture. We just went to 3rd grade, so that's just to let you know where we're heading and what this picture and why that circling and that moving of those 10 groups over is such a strong visual that our kids need to be doing. I know that you've got kids who can do it with the numbers, but can they visualize it and do they know why it's happening? I'm going to let you do 7 on your own. 6 and 7 are about recognizing the 10 tens and then being able to break numbers apart. Because I would like to get to number 8. I'm just showing you because your kids will be bringing home something like this. If it says prove, they need to be drawing 2 hundreds and 3 ones. These are the classic gotcha questions because there's an answer of 230 and there's an answer of 203. This is where kids who just grab numbers and don't think about them start making the mistakes. So if you can draw that picture, I can find the matching value. I've done it. Do I have to draw the picture? No, I'm visualizing it in my head. I can find the right ones. So you will be seeing work like this come home to your kids. And one of the last things they're going to do is start comparing numbers. Not just numbers written out as 47 and 147, but also how do you compare 2 hundreds to 14 tens? Back to that flexibility, back to that knowing how many 10 groups of 10s equal 100. In the beginning, this first question, well, I know that 4 is bigger than 1, so obviously 47 is bigger than 147. Here's a problem with my logic. And this is, again, this is why place value is so important. Because at age 6, 7, and 8, you can't just look at the digit that's there, and they're going to want to if we don't have them thinking about the number. So we can draw this and it becomes very obvious. Now I'm going to go back to my, I don't need to talk about that. These are, the program calls these number discs, and they're round. We happen to own square ones, so we kind of stutter. They're number tiles, they're number discs. They're just an item to use that we understand it. So you may be seeing a little bit of issue. So I've got 47, and I've got 47. Now visually, it's very easy to see that the 147 is the larger number, even though the digit 1 is smaller than the digit 4. As adults, it's hard to think that they struggle with this, but this is actually quite a big issue. We're talking about the value of the number, not that first digit. How about 2 hundreds compared to 14 tens? Oh, sorry, let's stick with the discs. Okay, I'm going to start over on this one. This should have been drawn. We're comparing this one, 2, 3, 4, 5, 10, 2 14 tens. But I know that 10 tens equals 100. And now I'm comparing 2 hundreds to my 100, and I can now easily see which one is larger and which one is smaller. Now the symbol itself, they've got a lot of quick, cute ways of trying to remember which symbol is less than and which symbol is greater than. You have crocodile math. It's funny because some mathematicians are totally, I don't know, insulted by the crocodile math. It's like, it's just a way to learn which way the mouth goes. I also saw a kindergarten teacher teach me, if you think of it as dots, there are more dots on that side, so the larger number goes near the 2 dots. This is just something, we would have it up in a room. We're not, do our kids need to learn it? Absolutely, but as we're learning the concept, we're not trying to trick them about how they memorize the symbol yet. They need to know it. We need to be able to read it properly. On your place value sheet, you'll see that there's a front and a back. This is a great tool for you to use at home. On the back, there are more number bonds. I would like to tell you, there is nothing about the number bond that says the whole number has to be at the top and the smaller units at the bottom. You'll often see them flipped this way. It depends. It doesn't matter though, is that you've got a whole amount. You have, 2 or 3 amounts over here that equal the whole. Nor do you need the pretty computer version. I mean, I probably wouldn't worry about keeping this paper around now that I know what it is, but you need to know that we need to be using place value charts and we need to be decomposing numbers. Any questions?
The number. Yeah, the number 2. And the one that says start with a bundle of 125 and count to 250. So if I made a bundle of 125,
But that one told you where to start.
yeah.
Okay.
But I just then you have to assume that he knows that you just have to put those 2 together. Or I don't know. I wouldn't know.
So really, the idea is that we want to know what they're going to do with this 125. If a child did this and tells me I'm starting at 125, or if a child drew it this way, we're just getting started. What I want to know is, so what are you going to do from here?
Yeah.
So, thank you. Do you want to go by tens? 135, 145, 155, 165, 75, 85, 95. At this point, a lot of kids might go to 200 and then go to 250 again. There's lots of ways. It's no one way is correct. It's about kids finding what they consider easy numbers. We call them easy numbers, we call them friendly numbers, we call them benchmark numbers. Other kids probably would start, my guess, if this is what we started with, they might go add the 5 immediately, get to 130, and then start going 140, 150, 160. So the idea of 125 is we want to make the numbers more complicated to see how they're going to add it up and to see that they have choices. If it was 179, I really can't imagine anybody starting to add tens at that point. I think most of us would start with a 1 to get it to 180. 5s we're a lot better with because kindergarten, that's what they do. Pre-K and K, 5s we're good with, so I'm comfortable doing that. When I get close to 100, I'm going to round it to that because it's such a friendly number, 200.
Would it also be fair to say, Carol, that they're growing developmentally out of a time where once upon a time you would still have children who would not start what comes after 125, they wouldn't count on. You'd have kids who would have started drawing all the 125. Then they have to understand that 125 is the starting point, and we're moving on from there.
By second grade, they should be able to hold a number in their head to start with and then move on.
So we just think of that development.
Really, that being able to hold a number is first grade. If you can't, we're going to help them. Yes?
I have a question. Do you prefer to write unit form or standard form for like 2 grade?
At this point, it would be the expanded form. So if it was, let me double check that I'm answering. I think I understand your question.
And why?
So if this was 268, I would probably, most times in this unit, because we're using and practicing our place value, I would break it apart by place value. So I would write 268. It's very easy for me to see that it is the same as my whole number. Were you asking me if you could do 200? No.
The unit, the 268, the same as the...
Okay, is this the same? There's nothing about a number bond that says that circle on the left is hundreds. And in fact, if I had a question, 268, how can I make this easy to myself? Can I show you at first grade level? If I had 7 plus 5, my number bond could be 7. I'm not even going to make it a number bond, but I want to break apart 5 so that I can make a 10. I'm not sure that I'm helping myself here. So I have this choice how I'm breaking this apart. In this particular unit, we're asking them to do, we're using place values, so they're probably going to do that. But I might have a reason to break this apart. I don't know why, but I might have a reason. Okay, I'll move it up. I have still conserved the value. They're still the same as, but because of whatever my question is, I may have a reason to break it apart there. So these circles don't, unlike a hundreds chart, where it tells you these are hundreds, these are tens, these are ones. These can be used in any order that you'd like, and you're making strategic choices, depending on the problem. Yeah?
So my daughter got some number where it said 430. How many tens does it have? So I then instead of saying 43. 43 tens which mean 430. But that isn't the answer. It's 3. What is?
Oh, I would have to.
There is nothing. I mean, before it, there's no explanation.
If it says how many tens are there, I think there are 43 tens in it. I would really have to see the layout of the page and.
Are they checking that they understand?
They're-
I'm just wondering if they're checking to understand that the 3 and 430 represents tens.
Right.
3 tens.
Do they know that in this,
Later, I guess that must be then I can be
what's, if they are asking what is the value of that 3,
It was
that makes
430, the number. Which is why the obvious answer to me was that there are 43 tens. But I think what
I never throw my teachers under the bus. I would be ecstatic, even if I meant, if I thought I was asking the kid what is the value of this 3, then it would be 30, or there are 3 tens in this one. If a child came back to me and said there are 43, I would be up on the table dancing for what a delightful answer. I can't guarantee. We do get a little bit into mindsets of thinking we know what we're asking. That's a poorly written question. And without seeing it and kind of knowing the context, sometimes it flows, but shame on us if we didn't take those answers.
It happened to me in the same number with my daughter. But the key for me, for her to understand that, is that there are 2 types of questions. Which one is, which is the 10? And the other one is how many 10s? So she was reading the question as the same.
And you know what? This is going to get into really, really picky language. In this one, my guess is they are probably asking that the answer is 3/10 because they're asking specifically about the way this number. They're not talking about the value of the number. They're talking about how this number is written.
Do you know what is the place value of?
Yeah. That answer, though, I mean, this is the world we live in and the way we hope we're teaching, is what a great discussion. What a great discussion. Okay, yes?
In this example number 2, from 120 up to 150, when you say count to 250, I find the children also can start from 1, 2, 3.
Right, yeah, and in that, it's a conservation of numbers. They should be able to hold that 125 by now. By second grade, they should be able to say, okay, there's 125, I'm going to count on. If a child's not, we have to meet them where they're at, but as they hear other kids saying, oh, they're starting at 125, if they don't understand it, they're going to start at 1. But if it's just, oh, I misunderstood the question or I didn't really get the format that she was asking for, this is why we talk so much in math. This is why they listen to each other and question each other. It's like, well, why are you doing it that way? And they, I mean, from 125 to the next number, they could have done it by ones. But hopefully when they hear somebody else do it by tens or by hundreds, they're going to go, oh, I would much rather do it that way. I mean, we are logical. Kids are logical, especially when they see what the logic is.
Excuse me, I got one of the, I think this is what they use during class education, and I just review it, and I'm sorry, I just want you to explain me number 1, because I don't know if it's right, wrong.
Okay.
I don't know what she's supposed to do, and it's not explaining this.
Okay, it's 10 after 9. So can I say anybody else who's interested in this, I'll be glad to answer it. However, if it's such a specific question, if you want or need to move on. The last sheet is a review of today. If you'd like to answer it to give me any ideas of what would be an improvement or other ideas, may I simply say there will be more of these all year. Every time we have a number unit, I will be doing one of these. If you'd like to write that down that we should, go ahead, but I am already. So I'll kind of save you some writing. So if you'd like to fill that out, it can just be ripped off the back and left to me. Otherwise, I'll be glad to address this question. If anybody would like, if you feel that your child is struggling and you would like to take some straws home, I have about 6,000, possibly 8,000. You could even take them home bundled. So you're welcome to raid that section up there. I personally like I like the colored ones better than the see-through ones. You might not. But you may not have the chips. Those belong in a classroom. I have to return those. So if you'd like straws, you're welcome to them. So can I? Oh, thank you. Just leave this. Yeah. And I've got a few minutes. Let me get to hers.
I just don't know what is she supposed to do with what she did is right or wrong. I don't understand.
The box and draw pictures of who you used to count from 1 to 300. They answered this like a subtraction problem as opposed to a counting problem. This is exactly the one where I would expect to see 90. The plus 100 was fine. That would have gotten them to 190. But it's counting. So as soon as you start subtracting, we're not really counting. So I would expect to see this. I would expect to talk from 190. Another 100. So what was it? It was down from 90 to... Right. So 90 was where we started. And then I would have added a 10. And I'd be at